Energy and chemical bonds. We learned in earlier years about potential energy. A great example is a rock on a cliff. It has potential energy due to its height. When it falls down, its potential energy will be released in the form of kinetic energy. This rock on the edge of a cliff is an unstable system. The rock could stay at the edge of the cliff for a long time, but once it's pushed over the edge, its potential energy is released. It keeps falling on its own. The rock at the bottom of the cliff is a stable system. No matter how long you wait, it will not fall back to the top. If you want to get it back to the top, you'd have to carry it there. You'd have to supply energy at least equal to the energy that was released when it fell down. Falling down is spontaneous. Once the rock starts falling, it keeps falling. No outside energy is needed. Falling up is non-spontaneous. It will not happen on its own. The only way it gets back up the cliff is for it to be carried there. Outside energy is needed. Unstable systems can stay that way for a long time. A rock can sit on the edge of a cliff for years, until someone gives it a push. That push is the activation energy needed to start the release of energy. Sometimes just a little push is needed, like in the case of this ball on a flat surface. Sometimes a bigger push is needed, like in this case. In both cases, the energy release will be the same, just the energy needed to get started is different. Here we see 2H becomes H2. H stands for hydrogen. This reaction is spontaneous. That means that it happens by itself. There's no need to add energy. In fact, this reaction releases energy. That's because the hydrogen atoms are more stable when joined together into an H2 molecule than when they are separated. You can think of two hydrogen atoms falling together to form H2, hydrogen gas. In the case of the rock falling off the cliff, the potential energy converts into kinetic energy. The same thing happens when hydrogen gas is formed. At the microscopic level, kinetic energy is observed as being thermal energy. Heat is released. Chemical bonds create a more stable system. They can be very strong. It can take a lot of energy to break them. In fact, the energy of the bond is equal to the heat that was released in forming the bond. Just like the energy needed to carry the rock back to the top of the cliff is equal to the kinetic energy released when it fell down. This spontaneous reaction can go in the other direction. So hydrogen gas can become two hydrogen atoms that are separate. But in this direction, it is non-spontaneous. The heat that was released to form the bond must be added back to separate the hydrogen atoms. The hydrogen atoms must be carried apart. Two separate H atoms are an unstable system. Once they get close to one another, they will form a molecule of H2, releasing energy. Apart, they're unstable, since it's just a matter of time until they come together, form a molecule, and release energy. Just like it's just a matter of time before the rock falls off the cliff.